Okay, so now we'll show you the demonstration of our automated light trap. The system operates as follows. At night hours, around 7 p.m., when the purse starts to be active, the system turns a UVA light automatically. Near the light source, there is a little IR sensor that generates electrical pulses every time a moth passes through. When a specific amount of pulses is reached, the fan turns on to capture the insect. Now let's take a look at the hardware. We have the Myosa motherboard, we have the OLED display, and right below it is the BMP sensor for temperature and pressure. For local storage, we have an SD card module working as a data logger and is backed up by the RTC module. And finally, in the power stage, we have buck converter, optocouplers, and some MOSFET to drive the actuators. Currently, we are testing this connected to power grid, but ideally, the design is meant to run autonomously using solar energy. Now on the OLED screen, we can navigate through two main menus. The first menu displays date and time, environmental measurement, and the status of the load. Now, by pressing the push button, we can access through the second menu, which shows the status of the configurable time windows. These windows tell us which modules are active. Let's take a look at the web dashboard, which we can access by connecting to the local network generated by the ESP32. On this interface, we can see the sensor measurements, the status of the loads, and the exact pulse count from the IR sensor. We also have a data history section where information is automatically organized in folders by date and month. We can generate charts of the variables, and this information can be easily downloaded as a CSV file or the chart as a PNG. In the configuration tab, we can activate the loads manually, even though the system runs in automatic mode by default. It is also possible to modify the fan duration and the insect threshold parameters, see the window status, and to modify the schedule of the operational windows and save the changes. In terms of connectivity, the trap can transmit data locally or connect to an external Wi-Fi network. Here we configure the network, and we can also modify the operation mode, whether to send data locally via Wi-Fi to the cloud or in a hybrid mode using both channels.